Welcome, this is section 10.4, and again, like every section, I'll have to repeat. You have to start with reading the textbook, take a look at the examples, and then use this video as a resource to help you with your homework problems. So without reading, if you're trying to use this video to help solve the questions homework problems, that is not going to be possible. And again, please keep in mind, I cannot solve and I should not be solving all the homework problems. So with that said, let's go ahead and take a look. So today we'll be looking at more derivatives, and this is going to be the composition of the function, which is the composite of the function. So if I have two functions, f of x and g of x, the composition means you are replacing x with another function, which is f of g of x. Okay, so in this case, the composition of the function is m and is set of all numbers x such that x is a domain of g and g of x is a domain of the function f. So let's take a look at the first theorem, which is the power rule. And again, I would like to keep it very simple. If I'm having a function, if I give you a function f of x is equal to x to the power n, the derivative, which is f prime of x, is simply n times x to the power n minus 1. That is how the power rule works. But if you have a composition of function, then let me erase this. Everything stays the same. It's n times u of x, n minus 1, but the thing that's extra is the derivative of u of x. This is all going to make sense once we start doing the problems. And again, chain rule, we are trying to find dy by dx here. And how do I find dy by dx? I will differentiate the function with respect to u, the function y, and I'll differentiate the u with respect to x. Keep in mind this is composition, so I have two functions here. One is f of x and the other one is g of x. Okay, now with that said, let's go ahead and practically work these out. Let me draw these lines here so you know. And practically work these problems out so you can see what they are. One more line here. There you go. And now let's go ahead and work with the problems. So here I have a function which is x cubed plus 8 of x to the power negative 5. And I'm trying to differentiate this function. Okay, very good. So let me write down the function here. I have f of x, which is x cubed plus 8 to the power negative 5. Let me cross check. Yes. To the power negative 5. How do I differentiate this? So f prime of x is equal to, you should know this formula, negative 5 x cubed plus 8 to the power negative 5 minus 1. And now I'm not done yet, because this is a composition of function. I have to find the differentiation of x cubed plus x. So times, I'm going to change into a different color so you can see. Differentiation of x cubed is 3x squared plus 8. It's a 0, so I'm not going to write that down. So keep in mind what you're doing is you're deriving dy by dx times dy by du times du by dx. That's why this extra differentiation is needed. So what you did here is dy by du times du by dx. That gives you the derivative dy with respect to x. Okay, so now that said, once I found the derivative, let me go ahead and multiply. This gives me negative 15 x squared x cubed plus 8 to the power negative 6. And that is going to be my final answer. And let's check if that is correct. Yes, it is, but all they did was they changed the negative powers to the bottom. So it's negative 15 x squared. And this whole thing comes to the bottom and becomes a positive. All right, let's try the next one. So let me go ahead and write this down. I have 8, 3x squared plus 5. So my function f of x is 8 square root of 3x squared plus 5. What I'm going to do is I'm going to rewrite this as 8 3x squared plus 5 to the power half. Why? Because I like to use the power rule. Now if I find the derivative of this, 8, it's going to be half times 3x squared plus 5, half minus 1. Am I done? No, because you left this whole function by itself. And what should you do? You have to find the derivative of that function, which is, derivative of 3x squared is 6x, derivative of 5 is a 0, so I don't have to put that down. Once I do that, let me go ahead and simplify this. 2 goes into 8 4 times, 4, 3x squared plus 5, half minus 1 is negative half times 6x. What I've observed in Pearson is they don't like to have negative powers. So let me go ahead and multiply 6x and 4, which gives me 24x. And what I'm going to do is I'm going to bring this down because it's a negative power. And this now becomes a positive power to the power half. You can rewrite this half as a radical 3x squared plus 5. If you forget to write radical 3x squared plus 5, or if you stop, or if you forget to change the negative to positive in your test, don't worry about it. You will still get points for it, okay? But usually keep in mind, Pearson does not like to have negative powers, and they like to change the fractions to radicals. So this fraction becomes a radical. This negative power comes down to be a positive. Okay, now let's go ahead and take a look at the next one. What is this? This is 4x e to the power 2x. So let me rewrite this one. I have the function f of x is equal to 4x e to the power 2x. Is that right? Yes. Now, here, I have more than differentiation. If you look closely, this is 4x. And here, this is another function, e to the power 2x. So these are two functions. And you might say, Miss, how can I see something like this? You can see something like this only if you practice and do more problems. So in your homework, if you work out a problem and if you think you need more practice, simply click on similar question and a new question pops up. So practice, practice, practice. And again, from the previous sections, this is the product, right, of differentiation. And how do we do it? If I'm trying to find the differentiation of a product, I will write the first function down and the derivative of the second function, which is e power 2x. The derivative of e power 2x is e power 2x. Remember, I have to find the derivative of 2x, which is times 2. I'm going to pause here for a second so you can comprehend. Plus, what about the next one? Remember the product functions. Let me see if I can pull that up. I am going to 10.3 and let me take a look at the first one here. This is your product rule. Remember product rule? If you have two functions, f of x times s of x, it's f of x, derivative of s of x, derivative of f of x. That's exactly what I'm doing here too. It's your first function times the derivative of the second function plus the second function, and the derivative of 4x is simply 4 times 4. And now if you look closely here, I have e to the power 2x on both the functions, and I also have this little 4 on both the functions. So I can factor that out. So when I factor 4 e to the power 2x, what am I left with? Here I'm left with 2 and x, that is 2x. Here I'm left with nothing, that means I have a 1. Now, if you multiply, you have to get back to the function. So this is going to be your final answer. It doesn't matter if you put 1 plus 2x or 2x plus 1. That should absolutely be okay. All right, now let's look at the next function. Here they say, next problem. Here they're asking me to find the derivative, find the equation of the line tangent to the graph of f indicated by the value of x. By now, we know that f prime, or the derivative of x, gives me the slope. Slope of what? Slope of the tangent. Tangent. What's the equation of the tangent? Y minus y1 is equal to m times x minus x1. And keep in mind, this x1 and y1 will be provided in the problem. Now that we know, let's go ahead and write. It is x. Let me write down the function. So the function is f of x is equal to x over, was that x? Yes. X over 6x minus 5 to the power 9. And they're asking me to find at x is equal to 1. So my first step is to find the slope, which is finding the derivative. So what I'm going to do, of course, you can use your quotient rule, which is right here. You can use your quotient rule and then simplify, but I am a big fan of the power rule, so I'm going to go ahead and use the power rule here. So let me show you what that means. I'm going to rewrite this as x 6x minus 5 to the power negative 9. Now I have one is 6x and my other function is, sorry, one is x and my other function is 6x minus 9. Now let's go ahead and use the power rule. So it's the first function times the derivative of the second, which is negative 9, times 6x minus 5 to the power negative 9 minus 1 times the derivative of 6x minus 5. Derivative of 6x is 6. Derivative of 5 is 0. So I'm not going to write that down. Plus the second function, which is 6x minus 5 to the power negative 9 times the derivative of x, which is 1. Okay, let me go ahead and simplify this one. X times 9 times 6, it's negative 54x. Negative 9, negative 1 is negative 10. So 6x minus 5 to the power negative 10 plus I have 6x minus 5 to the power negative 9. All right, now what we do is you're going to bring out something that is common. And how do I bring it out? So as you can see here, I have 6x minus 10. The smallest number always comes out. Keep in mind the negative numbers, the bigger the number, the smaller the number is. So 6x minus 10 is common. This is what I'm going to do. This is negative 54. Oops, I did not bring that down. So this is 6x minus 5 to the power negative 10. When I bring this out, what am I left with? Negative 54x. But this is negative 9. So if I take negative 10, look what I'm going to have. I'm going to have 6x minus 5. Now you might say, Miss, how? Let me show you. 6x minus 5 to the power 1. Negative 10 plus 1 is negative 9. Okay, so you always bring out the smallest power and make sure you compensate with the positive. Because when you multiply powers, when you multiply the bases, you add the powers. So this is 6x to the power 1. So when I multiply 6x minus 5 to the power 10 and 6x minus 5 to the power 1, I get negative 10 plus 1, which gives me negative 9. All right, now having said that, let me erase these powers so I can go ahead and combine them. And here I have 6x minus 5. Now you might ask, Miss, can I use the quotient rule? Of course you can. You can use any rule you can, as long as you get the right answer. Negative 54 and 6x is negative 48x minus 5. The way you would write this down, remember Pearson does not like negative powers. This is going to be negative 48x minus 5 over 6x minus 5 to the power positive 10. Right? This is going to be my slope. This is going to be the derivative, which is also my slope. And at what point am I finding the slope? I'm finding the slope at x is equal to 1. So my slope m is equal to negative 48 times 1 minus 5 over 6 times 1 minus 5 to the power 10. Negative 48, negative 5 is negative 53. And this whole thing is a 1, so I don't have to put over 1. So now that I have my slope, let me go ahead and write my equation. So my equation is y minus y1 is equal to m times x minus x1. My m is negative 53, x, my x1 is 1, y minus y1. How do I get my y1? You should know this by now. You will plug x is equal to 1 into the function f of x. And what is my function f of x? X over 6x minus 5 to the power 9, which is 1 over 6 times 1 minus 5 to the power 9, which is again 1. So my y1 here is 1. I'm going to replace that. Y minus 1 is equal to negative 53 times x minus 1. Distribute your negative 53, negative 53x plus 53 y minus 1. Add 1 on both sides, negative 53x. 53 plus 1 is 54. And that is the equation of the tangent at x is equal to 1. Because we've done these problems before, you should by default know that every time you find the derivative, you get the slope of the tangent. All right, let's go ahead and take a look at the next question. Here we have compositions. Let me show you an easiest way to work these problems out. Okay, so here they say give the domain of the function, domain of g, domain of m, where m of x, domain of f, domain of g, and the composition function. Okay, let me start with the first function, ln. Remember, if you're finding the domain of a log function or ln function, the function should always be greater than 0. That means any log function ln u, the domain should always be from 0 to infinity. It always has to be greater than. And keep in mind, it is not brackets because you don't have a log of 0. You cannot find a log of 0. That's why it has to be an open parenthesis. So the domain of a log function is 0 to infinity. Now next one, go ahead and graph this. This is going to be a quadratic. Domain of any quadratic function is negative infinity to positive infinity. And that is your domain of your function g. You can graph it and you will see you will have a function negative x squared 64, something like this. And as you can see, the domain is from negative to positive. For a log function, you'll have something like this. So it's from 0 to infinity. Now the question comes, how do I find the domain of the composition of the functions? What that means is you're finding log of, instead of u, you're going to plug in 64 minus x squared. So let me go ahead and do this. Remember, log of any function, so the value of this should be greater than 0. That means 64 should be greater than x squared. In the other words, x squared should be less than 64. That means when I find the square root, x should be less than -8 and +8, because square root of 64 is negative and positive. And when I draw the number line, -8 and +8, x has to be less than -8. X has to be in between -8 and +8. That means x has to be somewhere here. So the domain of that function is going to be -8 to +8. Okay? Well, the easiest way is to simply graph your function and see how it is going to look. And based on that, you can go ahead and find the domain. And again, log functions should always be greater than 0. And if you plug the value in between negative to +8, that is when your log function is going to be greater than 0. All right, now let's go ahead and take a look at the next problem. Okay, let me rewrite this problem. So let me go ahead and write this down. D by dx, so I'm going to write it as f of x. This is my function, 3x, x power 4 plus 1 to the power 6. All right, and what I'm doing now is finding the derivative of this function. So again, you have to be using your product rule. You should see that there is a product here. So my 3 of x is one function. X power 4 plus 1 to the power 6 is another function. Let's see how we can find the derivative, which is f prime, or I can say d by dx, right? So how do I do this? Again, you bring down your first function and find the derivative of the second. 6 x4 plus 1, 6 minus 1, times the derivative of x4 plus 1, which is 4x cubed, plus second function, which is x4 plus 1 to the power 6, times derivative of the first function, which is 3x. Let me simplify this one. I have, what do I have? 6 times 3. Let me go ahead and simplify this function here. Do I have anything else? Yeah, I have 3 times 6. Let me write this down. 3 times x times 4x cubed is 4x power 4. You're going to see why in a second, times 6. And you say, Miss, should I do it your way? No, you don't have to do it my way. But I just wanted to show you what is common in between these. So x power 4 plus 6, plus 1 to the power 6 times 3. Now, if I look closer, there's x power 4 plus 1 to the power 5. There's x power 4 plus 1 to the power 5 inside this. There's a 3 common, there's a 3 common. Now, let's go ahead and factor that out. I'm taking x power 4 plus 1 to the power 5 and a 3. When I do that, what am I left with? 6 times 4 is 24, x to the power 4, plus I've taken out 5 x power 4 plus 1s from here. So I have x power 4 plus 1 to the power 1, and I've already taken out the 3. Now, if I add 5 plus 1, I should end up with a 6. Now, let's go ahead and simplify this. 3 x power 4 plus 1 to the power 5. And if you look closer, 2x power 4 plus x power, 24x power 4 plus x power 4 is 25x power 4 plus 1. And that is your final answer. I don't have any negative powers, so I don't have to put them anywhere. There you go. And your answer does match. So step by step, very slowly, but don't forget to find the derivative of these functions. That way you will not go wrong. Okay? All right. Let's go ahead and take a look at the next problem. I like word problems because that brings all your learning to sense. The drug concentration in the bloodstream T hours after injection is given approximately by 5.45 e to the power t, where Ct is the concentration in milligrams per milliliter. Okay? Now they're asking me the first question, what is the rate of change of the concentration after 1 hour, after 5 hours? The moment you see the word rate, you should know that's a derivative. So let me bring this function down here. I have Ct, this is the blood concentration level, the drug's blood concentration level, and this is the equation. Now let's use common sense here. When I give you when patients get anesthesia for whatever reasons, the anesthesia kind of wears down, right? The drug kind of wears down in the bloodstream as the time passes. If you take Tylenol, the power of the Tylenol kind of reduces after 8 hours. If you take ibuprofen, so that's the way the drug kind of works inside the bloodstream, right? And that equation, here I don't know what drug they're talking about, but the way they monitor or check the drug concentration is by this formula. Now they're asking me for the rate. The moment they say rate, I know I have to find C prime, which is the derivative. So it's 5.45, that's the constant. And here, e to the power negative t is, remember you're differentiating with respect to the time. So the derivative of e to the power negative t is negative t times derivative of negative t is negative 1. It's like, what's the derivative of negative x? Negative 1, right? So this is negative 1. So the final answer is negative 1 times 5.4 is negative 5.45 e to the power negative t. Now, does this make sense? Let's pause here and say, does this make sense? Of course it does, because the moment you see negative sign, you know that the drug kind of wears down in your bloodstream. Now, let's put this into use. They're asking me after 1 hour. So they're telling me, hey, find out how much drug is left. What's the rate? What's the concentration per milligrams per hour for T is equal to 1 and T is equal to 5. So what I'm going to do is I'm going to plug this in. Negative 5.45 e to the power negative 1. Negative 5.45 e to the power negative 5. So let me go ahead and pull out my Desmos here. Hopefully my internet is working. Okay, so I don't know if you all can see this, but you know what, let me negative 5.45 e, you all can use any calculator because I don't want you all to email me and asking me, can we use Desmos in the test? You cannot. You can use it for your homework. You can use any calculator in the test, but because you're taking the test on Pearson, it does not let me use your Desmos. So here I have negative 2.0049. So when I plug this in, I get negative 2.0049. And let me go ahead and change negative 1 to negative 5, and I get negative 0.0367. I get negative 0.0367. What does that mean? The concentration of the drug in your blood is negative 2. And again, keep in mind, what is this here? This is milligrams per milliliter, right? Milligrams per milliliter. And you're differentiating with respect to time. So this is going to be -2 milligrams per milliliter per hour. If you see the negative, that means the concentration of the drug reduces, negative stands for reduction, reduces by -2 milligrams per milliliter per hour. After 5 hours, it is 0.367. I think they ask us to round it off to 2 decimal places. So this is going to be 0.04, and this is going to be 2.00 is 2. But keep in mind the negative sign tells you that it's decreasing. So this is going to be -0.04 or 0.04 milligrams per milliliter for 5 hours. So let's go ahead and take a look. After 1 hour, the concentration of the drug is not increasing. The drug doesn't increase. The drug's concentration decreases. You can just take an example of Tylenol or anesthesia to make it much more sense, at the rate of 2 milligrams per milliliter per hour. After 5 hours, it's not increasing, it's still decreasing at 0.04 milligrams per milliliter per hour. Okay, so that negative sign just tells you that the concentration of the drug is reducing. Now let's take a look at the graph. They said, hey, which graph is this? Again, because it's red, because of the negative T, the drug concentration does not increase. That's wrong here. The concentration of the drug is not going up. The concentration of the drug is going down. So I have two options. One is A and one is C. Now, the easiest way is let me show you something. The easiest way is 5.45 e to the power -t. Plug t as 0. What do you get? 5.45 e to the power -0. Anything to the power 0 is 1, so it's 5.45. That means at t is equal to 0, you should have 5.45. Let's zoom in here. At t is equal to 0, the drug value is 7, so it's not this. Let's move on to the next one. At t is equal to 0, if this is 6 and this is 5, this is in between 6 and 5, 5.45. So this is my right answer. Okay, so let me go ahead and, this is going to be my correct answer. This one. All right. Hope this helps. Again, please, I cannot insist how important it is to start reading with your textbook first. Look at the examples, look at the PowerPoints, and then start working on your homeworks. If you start with your homeworks, trust me, you will be frustrated, and it just does not work that way. All right, hope this helps.